Hello folks, welcome to today's video. In today's video we are going to be talking about angles and arcs and how they relate to each other. So like I said, we're going to be talking about arcs, and that is the first new term we have, an arc. An arc is any part of the circumference. So if we take the circumference of a circle, the whole circle, and we were to just look at a piece of it. So for example, if I took a pizza and I cut off one slice, the crust on that slice would be called an arc. And because of that slice that's being cut off, we actually end up making two arcs, right? We end up making the arc that is the crust of that slice, but we also have an arc that is leftover after that crust is removed, right? So we called those two arcs minor and major. So the minor arc would be the smallest distance between the 2 points where we would be making those cuts on my circumference, right? And the major arc would be the larger of the two distances, okay? An angle when we start looking at arcs. So what happens is if I were to take that arc, so for example, if I had this red line right here, the arc AB, right? And then I were to draw a angle from A to some other point on my circle and then down to B. What we call is that angle right here at C is an inscribed angle, an angle an angle formed by joining two endpoints of an arc to any point on our circle. Okay, and we could make the same type of angle, but instead of going to the edge of my circle, we go to the center of my circle. So from A to my center, O to B, and that type of angle is called a central angle. Okay, so inscribed angle and central angle. So a central angle is an angle formed by joining two endpoints of an arc to the center of your circle. So why do we care? Well, there's some interesting properties about inscribed and central angles. So the first property, central angles and inscribed angles. Okay, in a circle, the central angle will be twice as big as the inscribed angle that are subtended by the same arc. So what I mean by that is subtended might not be a word you've heard before, but basically they are made from the same arc. So if I had arc PQ, right, so this red line right here, so the inscribed angle PRQ right here is half as large as the central angle POQ right here. Or in other words, the central angle is twice as large as the inscribed angle. Okay, so it's a really interesting property about circles that when I start using these arcs and making these angles where they start and end on the arc, we end up finding that any inscribed angle will be half as big as its central angle. Okay, and all inscribed angles that are subtended by the same arc will be congruent. And congruent is a fancy math way of saying the same. So if I were to make, again, an arc from P to Q and draw an angle, so P up to some point in my circle, back to Q, and then do it again to a different point in the circle, so from P to some other point in my circle and back to Q, what we would find is that both of those inscribed angles actually have the same value. So they'd be the same. They'd be congruent. And then if I did to a third place around my circle, they'd be congruent as well, right? So we call these angles congruent because they are equal. They would have the same value, right? So let's, one more thing here. So if I took angles in a circle that are subtended by a semicircle, by cutting my circle directly in half, right, or the diameter, they will be 90 degrees. And that makes sense if you think about it, because my central angle here is 180. The angle of a straight line is 180 degrees. So any inscribed angle to that central angle is going to be half of that, or 90. Okay, so let's take a look at an example, right? So if I had some point O on my circle, and I had an arc AB, so here's my arc right here, and I'll use the highlighter to trace it. So here's my arc AB right here. Right? What we can do is we can find all of these missing pieces of information by using these properties. So if I wanted to find the value of x, which is up here, and the value of y, which is there, knowing that this angle over here is 55, well, what we can do is we can use these properties, right? So here's my arc AB. So from A to C to B, there is one of my inscribed angles, and from A to D to B, there is another inscribed angle. So because this angle here at C and this angle at D are inscribed or subtended by the same arc, they're both made off of this arc AB, they're going to be equal to each other. So what that means is the value of x is going to be 55 degrees. Okay? And y has a similar property. Because y is the central angle that is subtended by this arc AB as well, then y is going to be twice as big as those inscribed angles. So y is going to be equal to 2 times 55, which is 110 degrees. Okay? So that is the basics of this idea of finding your inscribed and subtended, inscribed and central angles by giving a little bit of information. So what we'll do in the next video is we'll take a look at some example problems. All right, so that is it for today's video, and I will see you all in the next one.